Hey everyone! Have you ever wondered how a magnet works? What is it about this piece of metal that allows it to stick to your fridge and hold your grocery list? Or how is it that a magnet can attract certain metals from far away without even touching them? In this video, we'll explore the fascinating world of magnets and find out how they work. At the most basic level, a magnet is a material that produces an invisible force field around it. This force field can be detected by certain materials such as iron, nickel, and cobalt. When a magnet is brought near these materials, the atoms inside them align themselves with the magnetic field lines of the magnet. This alignment causes the material to become magnetized, and it is this magnetization that allows the magnet to attract certain metals. But what causes the atoms in the material to align themselves with the magnetic field lines? To understand this, we need to take a closer look at the structure of an atom. All atoms have a central nucleus surrounded by electrons that are constantly moving around it. The electrons move in specific paths called orbitals. When an electron moves from one orbital to another, it can absorb or emit energy in the form of light. The color of the light that is absorbed or emitted depends on the energy difference between the two orbitals. Now let's consider a material like iron. The atoms in iron have unpaired electrons in their outermost shell. These unpaired electrons have a magnetic moment, which means that they act like tiny, tiny magnets. When we place an iron atom in a magnetic field, the magnetic moments of the unpaired electrons aligned with the direction of the magnetic field. This alignment of magnetic moments is what causes the material to become magnetized. But why do only certain materials like iron, nickel, and cobalt become magnetized, while others like copper, silver, and gold do not? The answer lies in the electronic structure of these materials. For a material to become easily magnetized, it needs to have unpaired electrons in its outermost shell. Materials like copper, silver, and gold have all of their electrons paired up, resulting in no net magnetic moment per atom. Therefore, they are not ferromagnetic and cannot be attracted by a magnet. Now let's see how this works with a real magnet like this one. When we place a magnet near an iron nail, the magnetic field lines of the magnet cause the unpaired electrons in the iron atoms to align themselves with the field lines. This alignment creates a magnetic domain within the iron. A magnetic domain is a region where all the atomic magnetic moments are aligned in the same direction. As we continue to move the magnet, the magnetic domains in the iron move and grow in the direction of the magnetic field lines. Eventually, the magnetic domains reach a critical size and the iron becomes Once the iron is magnetized, it acts like a permanent magnet and can be used to attract other magnetic materials. But why do magnetic field lines only go through some materials like iron and not others like glass or plastic? The answer lies in the concept of magnetic permeability. Materials that are easily magnetized have high magnetic permeability. In contrast, materials that are not easily magnetized have low magnetic permeability. Magnetic field lines can only penetrate a material if it has enough magnetic permeability. That's why magnetic field lines pass through iron but not through glass or plastic. In conclusion, magnets are truly fascinating objects that have the ability to attract certain metals without even touching them. By understanding the basic principles of magnetism, we can harness this incredible force for various applications, from simple things like holding notes on a fridge to complex technologies like magnetic resonance imaging. So the next time you see a magnet, take a moment to appreciate the amazing science that makes it possible. Thanks for watching, and I'll see you in the next video!